Should have sent you guys an email last night, and I had forgotten to.
I would have checked it. It's all good.
I was busy doing things. Obviously, we didn't have anything yesterday. Between today and tomorrow and Thursday, these are all going to be in section 3.4, with this being a little bit extra review stuff because we're going to test out of this first unit on Friday. So everything we've done so far, we're going to test out on Friday. It's a lot of review from what we did the first week of school. Last week we started to get into some of the newer things. We've all done systems of equations. We've all done graphing. What we started to work on a little bit more was these boundary areas. We did some absolute value stuff. We did some piecewise functions. But you remember, it was all pretty simple. Today it kind of starts to build into the 3-4 is what we call linear programming. It gives us a reason to what we've been working on with those boundaries that we're creating to help us come up with some feasible region, if you will. All possible values. The one problem we had a second, where you had the 4 equations, you wound up with of that boundary in the middle like this, where it worked for everything. Those were all your true statements. Well, what we're going to be able to do is figure out the intersection points, get those ordered pairs, and we're going to test them into what's called a constraint, an objective function, if you will. We build those into that, and then we start to take those into the real-life application problem, which we'll do tomorrow, for word problems. How do you come up with a system of equations with constraint to a real-world problem that deals with money and costs, and you want to maximize your profit, things like that. It sounds like it's really weird to work with, but yet it's relatively simple once you get through the minutia that's built into the words. It means something. It's a fancy way of saying it's a fun word. Speaking of poop, my nephew, we had a second birthday party for our nephew, and Grandpa bought him that Despicable Me fart gun. The funniest thing in the world to watch a 2-year-old run around with a fart gun. You know what I'm talking about. Have you guys seen it where you pull it? It just makes all these noises. Have you seen it?
No.
They sell it at Walmart and whatever.
You should pull up a video of it.
I do have a video of it, but it was just priceless. The laughter on a kid's face, because farts are funny. They are, you know they are. And it's just awesome, so. Whatever. Linear program. What do you think I'm gonna give you everything? No, I can give you little bits and pieces. So here's how this stuff works. You're going to do this constraint style problem where we're going to figure out bounded regions. And it starts with these constraints. These constraints are going to be the values that they give you. Tomorrow will be the values that you're going to come up with. For example, x is greater than or equal to 0, y is greater than or equal to 0. Does everybody agree that's a first quadrant problem? That means you are dealing with all positive values. This happens a lot when you're dealing with the word problems that we'll get into tomorrow, when you're talking about the bounded region, because you can't have negative gift baskets. You can't have negative amounts of seats on an airplane. So you know that you're always going to be dealing with that first quadrant stuff more often than not. All right? So what I do with these things is I never use graph paper. I think graph paper gets in the way of your brain because it makes you have to count. Whereas I want you guys to, use graph paper, I can yell at you, but what I want you guys to understand is that the graphs that we're going to create are for your own good to, it sounded awful like that, it's for your betterment, if you will, that visualize what in the world's going on. So when I see x is greater than or equal to 0, y is greater than or equal to 0, I know that all I have to do is that. It's a first quadrant problem.
Nice.
Okay? I know that it's going to be all these values going this way and all these values going that way. And then I start with my intercepts. If I go to the third constraint, I have a y-intercept of 5 and an x-intercept of -15. You okay with that?
Yeah.
So I'm gonna say this
I
is
think it is now.
5. And I kind of have to go back this way and just put that negative 15 here. And I'm gonna go,
Would you switch the signs, right?
when you're doing intercepts, you don't switch signs. You're just solving for x. I know what you're talking about though. That's when you're single variable going through it. But here we're just doing intercepts covering look. Now, obviously the x-intercept is out of my other bounded region. Do we agree? But in theory, does this line ever go through, or I should say theory, but in actuality, did it go through the origin?
No.
No. So is 0 plus 0 smaller than 15?
Yes.
Yeah. So its boundary is going this way now. So right now I'm bounded from
Down.
x is greater than 0, y is greater than 0, and I'm below this line. It's got a cap to it, if you will. Right? I do the next thing. The next one has a y-intercept of 12 and an x-intercept of 6. Excellent. So I put my 6 out here. Then I'll put my 12 up here. I connect those. And I check. Is 0 plus 0 smaller than 12? What I want you guys to see is that those two lines intersect each other. These two did. And I'm bounded with my region here. I have a 0, 0 for one spot, 6, 0 for the other, 0, 5 for one, but I need to figure out just that ordered pair. And in order for us to figure out where two lines intersect, we use that systems of equations that we talked about last week. Whether you're using substitution, linear combinations, anything like that, they all work. So what I would do is that I know that I can get x, I can say that x, by moving the 15 over and moving the x is 3y minus 15. And I can use substitution to solve for the ordered pair for x and y, to figure out what this point is. Because that's the only one in this case that I don't know. So using substitution, I know that it'd be 2 times 3x minus 15 plus y is 12. When you're doing the substitution or elimination methods to solve the systems, you can disregard the inequality. Just set it equal. Is that okay? Don't worry about the inequality part, because all you're doing is you're trying to figure out where they are equal. You could care less about the idea of it being less than or equal to, greater than or equal to at this point. You're just finding the x and y coordinate. So you just treat it like that. Excuse me. 6y minus 30 plus y is 12.
Where'd you get that, like the top equation, like the 2, 3y minus 15?
Here,
No, down. Yeah, that one.
Because that's what.
I got x by itself. I moved
Yeah.
the x over and moved this over, so x
Yeah.
is 3y minus 15.
No, the one below that then.
I used to substitute in. I substitute in for x here. That's all.
Oh, okay. I see.
So now I have 7y is 42, y is 6.
Actually, you just keep talking. I feel you.
All right.
All right.
If y is 6, what's x? 3. Excellent.
Wait, how did you guys just?
I substitute back here. I get 18 minus 15, and I get 3. So the ordered pair where these two run into each other is at 3 and 6. Okay. The idea here is that you're going to create some boundary, just like we were doing yesterday with the shading stuff, and you're going to find all the ordered pairs where they intersect, or if they don't intersect. Sometimes the shaded region might be pushing itself away. Sometimes it won't be a closed shape. In an instance like that, it might be, it won't have a maximum value. It might not have a minimum value. As we build this up into the actual constraint function that they give you, you will start to see how that works. Okay? It's really not that much different than what we did last week with the inequalities, except for that intersection point, which is the same thing we did last week with the system of equations. Okay? But I guess we got a bunch of football pictures this week. Oh, you're too cool? Don't you know what we do? If you're in the paper, you're not in the blotter, you get an autograph,
I
man.
have no idea what we do.
Oh, well, you're learning.
Sign your name.
Now you know.
Sign my name.
See,
He's like,
what,
oh god.
he's new, all right?
He's new.
What happens is,
Remember, we're gonna
whenever you're not in the paper, you're not in the blotter, you get to autograph your picture, and then we hang it up on the wall.
Really?
Yeah,
Same thing is pretty bad.
that's okay. My handwriting's awful too. But put it on the white part so you can
On the
actually see
white
it.
part, oh, okay.
Wait,
Because-
now you gotta erase what he.
That's okay. Oh, now you've gone and messed it up. Well, you might as well sign the other one then.
I think you scored on that ball. I did score on both those plays.
Oh.
Oh wait, use the other one. I'm sorry. That mark is a crap mark. That one doesn't work very well. Hey, while you're here.
That's oh. There's more. Is it all in there? Hey, you
Oh,
forgot. You
you
forgot about
didn't show
the
up.
E, man.
You can't even spell your own name. Wow.
What's something in the end? I'm not sure what that is.
I don't write my last name out, so I put T and scribble.
That looks like a T. That looks like an R.
It does look like an R.
It's okay. Oh, wait.
So the next step in working through this is that they're going to give you what's called an objective function. This is the objective function. They use the letter C for that. I'm not exactly sure why they use C, but they do. Did it bring call or not?
Yeah,
All right, cool.
I'm scared.
They use the letter C for the objective function, and that's, for today, that's going to be given, okay? That'll be given to you. You're going to take that value, and you're going to figure out, when you have those ordered pairs, you're going to use it to check which one of those sets of ordered pairs give you the biggest bang for your buck. Just think about the trail.
Oh, God.
Not the only.
Okay. So if I'm looking at this one here, notice what they gave you as far as your constraints. They gave you first quadrant right off the bat. X is greater than or equal to 0, y is greater than or equal to 0. And then you had something very, very simple to work with. X plus y is less than or equal to 8. So we draw out our first quadrant problem. I know that it's greater than or equal to 0, so it's going to be working towards the right and moving upward. We okay with that?
Yes.
So it's going to do this and this. I also know that my x and y intercepts from the next part are where? They're both at 8. Okay. Do I need to count 8, or can I just go, here's 8?
That works for me.
All you got to do, guys. I will tell you one thing as you start to play around with some of the values. If you have more constraints and your boundaries start getting out a little weird, you're going to want to try, if you have one that's at 8 and one that's at 4, try to put it halfway between the two. Try to guess your scale as you're drawing it. It does tend to make it a little bit more helpful because you might see the intersection values a little bit cleaner. That's all. You'll see it when it comes, when those problems show up. Connect them because it's a solid line. Notice, I did not extend the lines past the x and y
Why not?
because it's already outside, it would be outside the region.
Okay.
Okay, everybody okay with that?
Yep.
So now, what is your test point you're going to look at? 0, 0. Bless you. Very good. Is 0 plus 0 smaller than 8?
Yeah.
Yes.
Yeah. So it's moving inward. So what we have here is we have a region that was created by, if you look at it, the 3 vertices of a triangle. Okay? So the only other ordered pair I have to come up with there is the origin, which is 0, 0. Thank you, sir. So now you have basically 3 points that the functions change. Y-intercept, x-intercept, origin. So you're going to take these 3 ordered pairs, 0, 0, 0, 8, 8, 0, and you're going to substitute into your objective function to figure out which one gives you the maximum value and which one gives you the minimum value. Well, which one would be 0, 0? It would be the minimum. In this case, 0, 0 is going to wind up being our minimum. So when you substitute in, you get 3 times 0 plus 4 times 0 is 0. 3 times 0 plus 4 times 8 is 32. 3 times 8, oops.
Hold on a second. I know you got something.
So here, all we've done is we've taken those 3 ordered pairs and substitute in for our objective function. Which one's the biggest? Which one's the smallest?
0, 8 is the biggest.
Very good. So your maximum is going to occur at 0, 8. Here's my maximum. And then 0, 0 is my minimum. This is kind of the idea of how this works. Is let's say you made $3 on object X and you make $4 selling object Y. If you sell nothing of the third one and 4 of the other ones, you're going to make the most money. That's kind of what this is getting at. Okay? If you don't sell anything, you don't make any money, so that's your worst thing you can do is 0, make nothing. The best you can do is make $32 if you have sold 8 of one thing. And the reason why people say, well, why can't they sell more than that? Well, the constraint was given to you because maybe your inventory, you didn't have enough materials to make something. That's where these things come into play. This is a true application of a business model. It's the most simplistic business model you guys ever use. You ever had a lemonade stand? You only have so many lemonade packets your parents paid for, and you have to pay that back before you can make profit. Well, your minimum values would be at where you started out at and how you build out of it. This is a very simple profit function. Okay? Not that scary, is it? Nope. Let's try another one. Try another one here. You see that? It looks like a little. Lower this up a little bit. There, you can see it better. I say use quick graphs. I try to use quick graphs all the time. Those are just less than or equal to.
This is max value.
In this case, sometimes it'll ask you to find the maximum, sometimes it'll ask you to find the minimum.
So you're not.
Sometimes it'll ask you to find both.
Oh.
Okay.
I just thought you had to find both or something.
It depends. We can find both here. It's not going to be a big deal. It's relatively easy to
Don't
do.
you do it anyways, so. Use your luck.
You'll see how it goes.
I will.
All right. So in this problem here, we have x is greater than or equal to 2, x is less than or equal to 5, y is greater than or equal to 0, and the last one is y is less than or equal to 2x plus 12. We okay with that? Now, knowing that we're using quick graphs, the easiest thing for me to do is probably to rewrite that last equation. Move the x over to the other side because then I can do intercepts instead of trying to find my y-intercept of 12 and walk the slope. That's a pain. But if I rewrite this as 2x plus y is less than or equal to 12, do I really change it at all? I make it easier on myself as far as graphing is concerned. Everybody see how I did that? It just makes your life easier. I'm all about making things easy for you guys. Until tomorrow.
Yay.
You guys are gonna hate me tomorrow. It's gonna be great. This is absolutely one of my favorite sections in this whole book.
Why? Because it frustrates everyone?
It's not so much that it frustrates you guys, but there's so many things It's very intricate and very detailed. It's very detailed in what you can do, and the application of it is just, it makes sense that what you can do with this. I drew first quadrant because I'm bounded between +2 and a +5, so I'm in that range there. And it's everything up. Everybody okay with that? So basically I have this. Vertical line at 2,
I knew
vertical line at 5, and it's moving this way and that way, as well as moving up. Those are the first 3 constraints. Did everybody see how that worked? And now when I do my intercepts, I have a y-intercept of 12. And an x-intercept of 6. And I connect it. Is 0 plus 0 smaller than 12? Yeah. So it's moving inward. And then a little jump right here. Now, take a look at where all of these lines intersect for the ordered pairs. I have one here. We know that one is 2, 0. I have one here. It's 5, 0. I also have one here. But what's nice, I know what the x-coordinate is there. It's 2. By using substitution, x has to be 2 here. And now if x is 2, well, what's y? -4 plus 12 is 8. What's the x-coordinate for my other intersection? It's at 5. Here it's
Oh, I see.
5,
This
is
is
too many points.
and then the y value would be at 2. Very good.
That's too many points.
So you have
Really messy.
4 spots here. We've created a quadrilateral, if you will, that we're going to test our objective function. I have to test it at 2, 0. Does it matter the order in which you list them?
No.
Nah, it doesn't make a difference at all.
No.
2, 0, 5, 0, 5, 2, and 2, 8. And I want to find the max value, so it's -2 plus 3 times 0. -5 plus 3 times 0. -5 plus 3 times 2. And -2 plus, bless you, 3 times 8. Well, shouldn't be so bad for the first 2. -2, -5, 1, and 22. Where's the max?
22.
At 22, at the ordered pair of 280. Okay. That's how these things work. We're going to get some constraint, plot it out, find the ordered pairs, substitute directly into whatever that maximum or minimum objective function that they give you. How many words do you want?
Did I say 22?
Yes. Let's do one more, and I'll let you do it, okay? Find the max and min of that objective function with the 3 values. I'll give you a few minutes because we still got. X is greater than 0, so I'm going this way. I'm going to bring this back over, so it's -2x plus y less or equal to 2. I'm going to get x and y intercepts. I got an x-intercept of -1, a y-intercept of 2. There's 0, 2. Oop, and then -1, excuse me.
-1.
And I'm going,
Wow. What did I do?
I tested, is 0 plus 0 smaller than 2? So it's moving downward out of here, but it's coming up from here. All right.
Where did you get the -1?
I move the 2x over, cover and solve. Y is 2, x is negative 1.
Oh, take it.
Okay. Then the other ones are at 5 and 5. All right. Is 0 plus 0 smaller than 5? Okay, so let's move it down, move it inward. So we need to find this ordered pair. That ordered pair is where these two guys intersect with each other. So I use it as a system of equations. Not going to be that difficult because you've got y is 2x plus 2. So 5 is x plus 2x plus 2. Bring the 2 across, so you get 3 is 3x. So x is 1. What would y be? 4. Very good. Oh, there's plenty of ways of doing it. Absolutely.
I found why.
Oh, that's fine. There's nothing wrong with that. Absolutely. When we get into systems equations, there's no wrong way of doing it unless you do it wrong.
I did it wrong.
So you have your ordered pairs then at 0, 0, because this one isn't in our region. We're at 0, 0, 5, 0, 1, 4, and 0, 2. This one we're good. So let's see, 0 plus 5 times 0, 0. Convenient. And it's pretty obvious to find your maximum. Your maximum value would be at 1, 4, and your minimum value would be at 0, 0.
How do you find the 4? How do you find the 4?
I use the system of equations. It's where two lines intersect, so I'm solving the systems of equations of y equals 2x plus 2, and x plus y is 5.
Okay.
So we're looking for the intersections here. Problems I want you guys to do tonight, because we're gonna have a couple of days worth here.
Wait, how come you did 5, 0, but not negative 5, or 0, 5?
Y.
It's not. It didn't wind up in the region.
Oh, okay.
So when you have, and that's when I start drawing these things inward. This was in here, but then this line here superseded that boundary, so it cut it down a little bit. Same thing with the x value being cut to the right. I didn't have to worry about anything in here. So you're looking for that feasible region range.
Okay,
All right. So this is what, 3, 4. It's on page something.
I'm gonna cry.
So this is on 166. I'd like you to do. Which one is this here? Let's start with 14 through 20. Do 14 through 20, okay? Page 166. 14 through 20. All right, 7 of them.
Okay, that is 14.
The intersections should be okay. I will say, I think it's on number 19. You might get a weird intercept if I'm not mistaken. I try not to give you too crazy one, but give those a shot. We'll build out of it. Good luck. Have a great day, ladies and gentlemen.
Are you teaching me normal algebra classes?
No, I just have. Yeah.